All right, lesson 2.1, solving linear equations and inequalities, with a few little advanced moves in here, things that'll help you on the SAT. So starts off kind of easy, but a few things we need to knock out. All right, so number one, I look at this, I can tell it's linear. There's just all x's. There's no x squareds or anything to worry about. So I'm going to distribute here, and I get 5x minus 40. Remember, that's a negative 1. So negative x, negative 6. SAT always has one of those on there. Now I have to combine some like terms. So I'm like, all right, 5x's, subtract 1x. That's going to give me 4x's. I have a negative 40 and a negative 6. That's a negative 46 equals 18. Trying to isolate the x term, I got to do the opposite and add the 46 to both sides. So I do that, cancels out. 4x equals, that would be 64. And last move is divide both sides by 4. And you get x equals 16. All right. If you're getting fancy and you're using set notation or something like that, you know, the solution to this problem is 16. And we'll get a little bit more into that here down the road. Number two, so I have a fraction. What I do not want you to do is I do not want you to punch in 1/3 times 2 and get a decimal. No decimals. All right? If the question has fractions, we give the answer, we do our work in fractions. So no decimals. And I usually, my first move is going to be, I'm going to try to clear fractions out. So like right now, this 1/3 is being multiplied by that parentheses. I could distribute 1/3, but I'm going to multiply both sides by the denominator. I'm going to multiply both sides by 3. So I'm going to multiply this side by 3, and I'm going to multiply this side by 3. I don't have to multiply all this stuff in there because that 1/3 is already kind of being taken care of. So I don't have to worry about that. So I distribute through, and instead of 1/3 of 2x minus 7, when I times 3 of those, it ends up just being a 2x minus 7. On the right-hand side, I get a 12. Now I'm going to add 7 to both sides. And some of these I might not show every single plus to both sides. And then when I divide it out, divide by 2, divide by 2. This is usually how we're going to leave our answer, just as an improper fraction. Now I know that is, that's actually 9 1/2, which is a mixed number, or it's 9.5, which is the decimal. But 9 times out of 10, we're going to leave it as an improper fraction. Now, you could have, if you wanted to, you could have did that problem a little bit differently, and you would have ended up having to deal with fractions like throughout the problem. So you could have said, well, 1/3 times 2 is 2/3 x. 1/3 times 7 is minus 7/3 equals 4. Now it just gets kind of weird, because then you have this 2/3 x. When I add 7/3 to both sides, I got to add 4, plus the 7/3, because if I do it to this side to get rid of it, I got to do it to the right side. And now I got to say, well, I can't really add 4 and 7/3, so I got to change 4 into thirds, which would be 12/3. So now 12/3 plus that is 19/3. And then to solve for x, I either need to divide both sides by 2/3 or multiply by the reciprocal. And then 3's cancel out. Eventually I get 19/2. I'm very seldom, if ever, probably never going to do it that way. I'm always going to clear out fractions by multiplying by the denominator. So I'll show you that in a few other problems, when we get into the homework and things of that nature this chapter. Number 3, I have x's on both sides here, so nothing to do on the left. Distribute on the right. I get 6x plus 24. So now I got to get all my x's to one side. Some people always put the x's left, the numbers right. I usually always put them on the side where there was more to begin with, because I like having positive x's. So I'm going to subtract the 6x from both sides. If you want to, right now, you could, I know I'm going to be getting rid of that plus 20. So I like to do 2 steps at once. So I'm going to encourage that. in honors to do 2 steps at once, save a little bit of time. So that's 6x equals, I guess that comes out to be 4. And then when I divide both sides by 6, and I reduce that fraction, we get an answer of x equals 2/3. So you can do 2 steps at once. I'm cool with that. This next one, I have to distribute the -2. So I have 4x, subtract 6, subtract 4x equals -6. Don't start doing anything to both sides just yet. I like to combine like terms first. So I have 4x minus 4x. So that goes away and becomes 0. So now I just have -6 equals -6, which I could carry it down further. But this is what's known as the identity. So it's just kind of a vocabulary term that, this is an identity equation, meaning that you end up with the exact same thing on both sides. So it's kind of like if I started off and said, hey, solve x plus 1 equals x plus 1. Well, any number I put in there for x is always going to work, no matter what I plug in. So the solution for this one is all real numbers. So when we do the teacher made, I'm going to enter it in as all real numbers. Some people call it infinite solutions. That could be something else that you may see on a test somewhere. But these two both mean the same thing. All real numbers or infinite solutions. So that's what you have to write. And basically what happens is all your x's disappear and you end up with a true statement down here. When it's a true statement, that means that any x can be plugged in and they'll all work. So kind of a freak case, I like to call it. There's a couple of those that shake out. Number 5. Just have 8 on the left. I have a -8x here. Positive 4 gets distributed. Positive 4 gets distributed. Similar scenario, I end up with 8 on the left. This -8x cancels with that positive 8x. They combine to make 0. Now I end up with 8 equals 16, which I'm like, that's not true. So that's a false statement. What that means is there is no solution to this problem. This problem is impossible to solve. There is no x in the world that will ever make it true. An example of this, the classic, is x equals x plus 1. There is no x you could ever plug in there because the right side is always going to be 1 bigger than the left side. So when that happens, we say that there's no solution. If you're using set notation, you basically put a set with nothing in it. This is referred to as the empty set. So whenever you have no solution, you could also call it the empty set. Some people call it the null set. And they'll actually put a little 0 with a slash through it. So these are just different ways I've seen it expressed. But unless I ask for a specific notation, I'm going to prefer you to just say no solution. That's kind of what the SAT does. The SAT doesn't really bother with those two fancy set notations down there at the bottom. Number 6, first thing that I notice is, hey, we have a fraction. So what am I going to do? I'm going to clear the fraction by multiplying by the denominator, by the 2. So I'm going to multiply that 2 through. I could do it now if I wanted to, and I wanted to multiply by less pieces. I could also start off by moving that 40 to the other side. So I think I might do that. I might, on this problem, add the 40 to both sides. And that gives me 3n equals 1/2 n plus 75. And now I'm going to multiply everybody by a half. So or everybody by 2. I got to multiply u by 2. I got to multiply u by 2. And in this case, I have to multiply the 75 by 2. When there's parentheses and the fraction is out front, you don't have to multiply it through the parentheses. It's already taken care of. But there were no parentheses here, so every piece gets times by 2. So I end up with 6n equals 2 times a half just squashes each other, gives me 1n plus 150. Now I'm going to subtract that 1n from both sides. And you get 5n equals $1.50. Divide by 5, divide by 5. And we find out that n equals 30. Again, you could jumble up the order. I could have times everything by 2 first. I could have actually subtracted the half n to the other side, but then I got more fractions. So there's a lot of different ways you could attack it. If you did it a different way and you want some clarification, ask me in class. We can take care of that. All right, solve and graph each inequality. Write the solution set in 2 different ways. So this is something that you're probably not familiar with, so you might want to pay attention. Set builder notation and then interval notation. 2 different animals. I feel like you've probably have solved inequalities before, so I don't think that's going to be a huge part of it, but the notation is going to be a little tricky. So when I want to solve an inequality, inequality just means they're not equal. There's no equal sign there. I'm going to handle it just like algebra. I'm going to ignore that sign for a second. So I'm going to just pretend for a minute it's an equal sign. And I'm just going to do my steps. I'm going to minus 8 to both sides. Boom, boom, boom. And I get negative 3x. And then I get my 6. Here's where the sign matters. So I'm going to put it right back in. Whenever you have an inequality symbol, there is a rule that says if you multiply or divide, so if you multiply or divide by a negative number, then you have to flip the inequality symbol. All right? So there's a negative 3 times x. I need to divide by negative 3. Divide by negative 3. And right there, I'm like, oh crap. I just divided by a negative. So that means I'm about to flip the sign. So the sign is now going to go this way. And that comes out to be a negative 2. So normally I'd say, okay, there's your answer. X is greater than or equal to negative 2. Well, I just did the solve part. So we solved it. Now what we need to do is we need to do the graph part. So now I want to graph, and I don't mean graph like on a coordinate grid. I mean graph on a number line. So now I want to show where all these solutions live on a number line. I always slap a 0 in there. And, I could put multiple points, but I don't really have to. But if I want to show x is greater than or equal to negative 2, I'm going to come over here to negative 2. I'm going to put a circle there. Now, since this symbol can be equal to, since it also could be equal to, I'm going to shade that circle in. Because not only is negative 2 the boundary, but negative 2 actually makes my original equation true. So when you have that little equal to sign, you close the circle, you shade it in. And now I want to show all x is greater than negative 2. Well, on a number line, greater than negative 2 is going to be everything going that way. All right? So that's what it means to graph your solution. Solve it and then graph it. Now, the other couple little pieces here are set builder notation. So set builder notation is kind of a fancy way, and here's what it goes. You put a set in, and then you put an x, and then you put this line in here, and then you write the part that we solved it. So this is called set builder notation, and I'll explain the pieces. So this is set builder. And I basically just read this. This is what it says. It says all x's, okay, such that x is greater than or equal to negative 2. All right, and here's what part translates to what. So the all x's is just this first piece. This line is the such that. And then this expression was the x is greater than or equal to -2. So it's just kind of a fancy formal way of showing the solutions. All x's such that x is greater than or equal to -2. So that's called set builder notation. Last but not least, interval notation. That's this one. Interval notation basically says, well, what interval do the numbers work for? Well, our left boundary is -2. All right. Our right boundary goes forever. So I'm going to just put infinity in there. And then there's this kind of idea of whether it's going to be a hard bracket or a soft bracket. Because this thing is closed and it has this little equal to bar on it, I put a hard bracket there. So that shows that -2 is part of the solution. And on the infinity sign, normally we just put it soft. So, and then the next example, you'll see kind of the flip side of this. But so on this one, my answers, the interval goes from equal to -infinity, that's what this hard bracket shows, or -2, I mean, all the way to infinity on the right. And you just kind of write it in that notation. So this is what interval notation is. And that was a lot of explaining. Hopefully number 8 maybe makes a little bit more sense. I'll go a little bit quicker. And that one should be a little easier. So let's work it out. We'll do our algebra. We got 3x minus 3 greater than 7x plus 21. Boom, boom. I'm going to get all my x's to one side. So depending on which way you want to go, if you want to move them to the left, fine. If you want to move them to the right, fine. I'm going to move them to the left just because I want to remember to flip that sign. Show that again. So I'm going to move my x's to the left, which means I want to move these numbers to the right. So I'm going to have -4x is greater than 24. Divide by -4. Divide by -4. And I get x sorry about that. I get x, and I got to remember to flip the sign because I just divided by negatives. So flip the sign, -6. So this is just kind of your standard answer. X is less than -6. And if I wanted to graph that, I put my grid on here, put a 0, I got a -6 on there somewhere, and less than -6 means I'm going to leave an open circle because -6 is not part of the answer. There's no equal to on my inequality symbol. And then less than -6 means we're going this direction. These numbers get smaller than -6. So that's my graph. Now if I want to do set builder, maybe I'll just call it SB. If I want to do set builder notation, my answers are all x's such that x is less than -6. I don't know, it's just a fancy way of writing what I already wrote. Now interval notation, be kind of careful. So my interval is the correct answers, they start at -6, but they go all the way to -infinity because they're going to the left. So infinities always are soft. Well, in this case, my -6 has a soft parenthesis because this circle was open and because there was no equal to sign down there. All right? So just to kind of go off the grid, if you want to put your own little scratch notes here, basically, when you have less than or equal or greater than or equal, all right? I don't like how that looks. Less than or equal, greater than, why am I zigzagging it? Greater than or equal, you're going to have a closed circle, and it's going to create hard brackets on one end or the other. All right? If you have less than or just greater than, it's going to be an open circle, and it's going to be soft brackets. All right? So I don't think we have any of this lesson, but you may run into something where we have like -5, less than or equal to x, less than 7. And if I were going to do this in interval notation, or in graphing notation, you know, I would have my 0, I'd have -5, I'd have 7, And I'd say, well, x's are greater than or equal to -5, so they're heading this way. But then at the same time, they're smaller than 7. So notice the circle on the left is solid because of this equal to bar, and the other one's open because of that bar. And then if I did my notation, if I did my interval notation, I would have a hard stop on the -5 because it's closed. And then I would have a soft stop on the right side because it's 7. So hopefully that cleared things up a little bit for you. Keep on going. We got a couple story problems to finish this thing up. A little geometry from number 9. So application time. Solve for x and find the measure of each angle. So there's no equation. I got to come up with my own equation. And I got to kind of use the fact that, hey, how many degrees are in a triangle? Hopefully you guys remember this from last year. Triangles, the sum has to be 180 degrees. So I know that this angle plus that angle plus that angle all have to add up to 180. And I combine some like terms, 1x, 3x, that's 4 total x's. Subtract 20 is 180. Add 20 to both sides, I get 4x equals 200. Divide, x equals 50. So it said solve for x, x is 50. Find the measure of each angle, I got to plug it in. So I think this angle A is going to be 50 degrees. Angle B is 2 times 50, or 100 degrees. And then this last one is going to be 50, take away 20, which is 30 degrees. Double check your answer. 50, 150, 180. Life is good. Everything checks out. All right, number 10. A salesperson at a jewelry shop is paid a salary. Salary means you get that money no matter what. $500 a month plus commission. All right. Commission means you get a percent of your sales. You sell more, you make more. There's a lot of car dealers that I know, they get 0 salary. If they go up and they work for 10 days and they don't sell any cars, they make 0 money. All right. Some sales jobs have a salary, some don't. This particular job, you're guaranteed $500 plus you get commission, which is 15% of all the jewelry you sell. Set up and solve an inequality to find the value of jewelry that they must sell in a month to earn at least $4,000. First of all, so this is how much money I make. So the money I make, I want to be at least 4 G's a month. Sounds like a lot of money, but $48,000 a year isn't a huge amount of money. So let's try to hustle to get this $4,000 a month. So I'm going to translate this. At least means I want to be greater than or equal to. I want the money I make to be bigger or equal to $4,000. Well, how do I make my money? I make my money by getting $500 a month. So $500 a month. Plus, I get 15% of my sales. So let's just say X are my sales dollars, how much I sell. So 15% of that, 15%, I got to do 0.15 X. All right, because when you do a percentage, you want to find 15% of a number, you change it to a decimal and multiply. So now we have an inequality we need to solve. So I'm going to take away the 500 from both sides. And that leaves me $3,500. So I take, if you didn't get formal with an equation, you'd just say, well, let's take away my guaranteed money. So now I got to make $3,500 in jewelry sales. It's a hard word to say, jewelry. Now I'm going to divide by the 0.15, divide by the 0.15. And since I divided by a positive number, do not flip the sign. Be careful. Don't flip the sign. And I got to divide this out. So now is where I might jump to my calculator and type in 3,500 divided by 0.15, 3,500 divided by 0.15. Whew, I got to sell some jewelry. $23,333.33. Man, I got to sell $23,000 worth of jewelry this month. Now, depending on where I work, maybe you work somewhere where they sell $7,000 watches or, a $7,000 engagement ring. So you may not have to make a ton of sales that month if it's a high-end shop. Or if you're selling $400 rings, you're going to have to sell a whole bunch of them. So answer to this question is, I would have to sell at least $23,333.33 if I want to make $4,000 per month. All right, this is just a little sprinkle of what you're going to see. So give the practice a try, and you can talk to me in class about any questions you have. See you.